Hello and welcome back to Calculus 1, section 5.4 on working with integrals, i.e. just a bunch of formulas that we can use if the stars line up in that particular way. So far we learned that we can calculate area under the curve with the definite integral a to b f of x dx. We also learned that if the function dips below like this, we can still find area, but we have to be very careful. So you will calculate a to c of f of x the normal way. Then you will stick integral c to d in the absolute value. And then d to b would be normal. So we know that because of the formula we've seen earlier, that you're allowed to break this interval anywhere you want. The next order of business is to also see that, I'm not sure if I mentioned this one or not, this was supposed to be one of the older ones as well. If you calculate a to a, f of x dx is 0. And that should immediately make sense because you are actually working on a capital F of a minus another capital F of a because they're the same value, and that gives 0. So this formula kind of should be obvious. And one formula that will be used again in Calc 1 here in 5.5, if you need to switch the limits of integration, you can do so, but you have to put the minus sign in front. So these are the formulas which you guys have seen before. You can calculate the area. If the function dips below x-axis, you have to isolate that part and put it in absolute value if you want the area. If you don't want the area. So this is positive energy, negative energy, positive energy, where in this case everything was positive, right? So we did not need absolute value on the upper integral, but you do need in the integral below, in the middle, right there. So all of that stuff is great and awesome. Now, the formulas that we are covering in 5.4 have to do with even and odd functions. Those are the first two. Now, the question is how much you remember from your pre-calc. So function is even if there is this rule. If this rule is satisfied, and function is odd if this rule is satisfied. There we go. So those are the two rules that we have. Now, the two formulas that I'm going to write now are like a quality of life formulas. Your pass or fail of Calc 1 or 2 doesn't depend on knowing these formulas at all. But if you do know them, they can cut out some calculations for you. So here is the first one. If you have f of x dx on a symmetric interval. Notice that it's negative a and a. So negative 3 and 3, negative 5 and 5, negative 10 and 10, right? So there has to be the same number with just the negative. So one is on positive, one is negative. So it has to be what we call symmetric interval. And if f is even function, then you can instead compute 0 to a of f of x dx. So you are actually eliminating calculating at negative a in favor of multiplying the entire integral by 2. And that's really cool. You can see this at our favorite even function. Cosine x is even. And if you draw cosine x like that, and let's say this is your a and negative a, you see that these two parts are the same. So just computing the first one from 0 to a and doubling it, because there is another one on the other side stretching to negative a, you're good to go. So a good example here would be, let's say, negative pi over 6 to pi over 6 of cosine x dx. And instead of this, you're computing 0 to pi over 6 cosine x dx, which is easier to compute, right, later when you figure these things out. So integral of cosine is sine, so you have 2 sine x from 0 to pi over 6, which works out to be 1, because sine of pi over 6 is 1/2 and then times 2. So it's really cool thing. Integral of cosine is positive sine, and then you have your 0 to pi over 6, that's sine of pi over 6 is 1/2 times 2 is 1. Done. The second formula, as you guessed it, is when f of x is odd. And then the integral simply equals to 0. So you don't even have to compute it. If you know that your function is odd and you have a symmetric interval, it's just 0. Now, easy example of this would be, let's say, x cubed dx from negative 2 to 2. Right? You immediately write 0 and you move on, because that's odd functional symmetric interval. But let's say you don't know that. Well, in that case, you have to integrate and compute everything, and you will get 0 if you do everything correctly. Obviously, you will get 0 anyway. So this is going to be 2 to the 4th over 4 minus negative 2 to the 4th over 4, and 2, 4, 8, 16 over 4. So this is 4 minus 4, which is a 0, which you could have claimed long time ago, right, if you knew that's odd function and so on. Now, obviously, these formulas apply in a very, very narrow number of problems. It's not just enough to have even an odd function, but you also have to have symmetric interval, and that's a problem, right? So these formulas are not going to work if your interval is negative 1 to 3, because it's not negative 1 to 1 or negative 3 to 3, right? So this is why it says negative a and positive a, and a being the same number as a, the one negative, one is positive. So be careful, right? These rules are to be used only when all of the conditions are met, and that is function is even or odd, and then your interval is symmetric. So if I come up with a problem which says negative 2 to 2 of e to the x dx, right? You actually have to do this, because e to the x is not even or odd. It's neither, right? So you would actually have to go e to the x computed from negative 2 to 2, and you get e to the 2 minus e to the negative 2. which is technically e squared minus 1 over e squared. E to the x is not even, not odd. So the formula doesn't work. Even though you have the negative 2 and 2 symmetric interval, the formula does not work. So formulas above do not work in this case. So a lot of conditions, right? You need to have a symmetric interval, and then you need to have even or odd function. Now, if any of those conditions are not present, tough luck, right? Tough luck. And the last formula that we need to cover, which actually has two sides of looking at it, is the average value of a function. Average value of a function. And that says that average value, which is f with this bar on top, is 1 over b minus a of integral a to b of f of x dx. Now you might say, what is this for? Why would we bother? Well, you can calculate the average height of a wave because each wave looks like, right, trig function does this, and we can figure out the average value of the height of each one of these, because these could be your waves, and then there could be a ship there, you know, or something. So these things are actually important in science. We can probably find some of. Let's find a homework problem where they're asking us to find the average elevation, average velocity, average height of an arc, average height of there. Here's average height of the wave on problem 38. Let's go with the average velocity, and then we'll do the wave. Average velocity, when the velocity function v of t is given as t squared plus 3t on the interval 0 to 6. Well, that's not a problem. To calculate average velocity, we are going to say average velocity is 1 over b minus a, that's 6 minus 0, integral 0 to 6 of t squared plus 3t dt. So it's going to be 1 over 6, and now I have t cubed over 3 plus 3 times t squared over 2, computed from 0 to 6. So all I did is I plugged everything in and then integrated each one of these parts, and plug in 6 everywhere and 0 will cancel. So 1 over 6, I have 6 cubed over 3 plus 3 halves times 6 squared minus the big fat 0 from the other terms. That's 1 over 6. Now this is 6 times 6 times 6 divided by 3, so one of these cancels, gives us a 2. So that's a 72 minus, and over here you have 3 times 6 over 2, so that cancels there. And you get 3 times 3 is 9, times 6 is 54. I just want to use the calculator. Faster this way. So 72 minus 54 is 18. over 6, the whole thing is 3. So average velocity is 3 meters per second, feet per second, miles per hour. I don't care, right? But that's the average speed. Now, the average height of a wave. They say that your height of the wave is measured by y equals 5, 1 plus cosine x for negative pi to positive pi. And you want the average height of a wave. Well, the average height, which is y average, is going to be 1 over pi minus negative pi integral negative pi to pi of 5, 1 plus cosine x dx. You can kick 5 outside, so average y is 5 over 2 pi, right? Minus and minus will give us plus, so pi plus pi is 2 pi. And then we have the integral negative pi to pi of 1 plus cosine x dx. Guys, we have symmetric interval. And if you have symmetric interval, that means that you can you need to check whether the function is even or odd. And if it is, you get to be a little lazy. So cosine is even. 1 doesn't change even values because it just shifts everything up or everything down. So yeah, this is even, which means that I can solve this actually by 2 times the integral from 0 to pi of 1 plus cosine x dx. That's us using the formula. It's called the mathematical flex.
I'm a bit confused. How is a cosine a positive? Even? Sorry.
Cosine is even function, right? Because it's symmetric on the y-axis. So the cosine is symmetric on the y-axis, and that's the property of even functions. And odd functions are symmetric to the origin, like sine is odd. Now, by any chance, are you going to Calc 2?
Yes.
Good, because you will have another way better answer once you are in chapter 11 of Calc 2. So hopefully, right now the only thing I can do for you is draw a graph and say it's symmetric on y-axis, and it follows the formula I gave before. But once you get a Calc 2, right, depending on whether your teacher shows this thing or not, you will know in Calc 2 why your trig functions are even or odd the way
I was
we claim.
just looking at exponents. I was like, oh, that it's to the 1 power, so it has to be odd.
That's exactly what it is. Because you will learn that cosine can be written as a polynomial in Calc 2. And it will be 1 plus x squared over 2 minus, no, it's 1 minus over here, and then plus x to the 4 over 24, and then minus and all of the exponents will be even. So you will see that cosine is even function. But again, you have to get to literally last chapter of Calc 2 to find out that. So just hang on tight, all right? So now we have our 5 over pi, and when I integrate there, I'm going to get x. Integral of cosine is positive sine, so plus sine x computed from 0 to pi. And when you plug in the values, you get 5 over pi. You get pi plus sine pi minus a big fat 0. When you plug in 0 for x, and sine of 0 is 0 as well, so that's a big fat 0. Cosine of 0 is 1, so you have to be careful, but sine of 0 just dies. And we get that our average value is 5 over pi plus sine of pi is also 0, not plus, times pi. They cancel, and you just get 5. Which, yeah, it makes a lot of sense. If you take a look at your original function, it's 5 cosine x plus 5. So if you learned your trig, right, you have y equals 5, 1 plus cosine x. If you distribute this 5, you will have 5 cosine x plus 5. So what do we know? We know that amplitude is 5, and this is 5 up. So when you graph this monstrosity, you will go like this. Is your x-axis, this is your y-axis. Cosine is going 5 up, which means that the middle line for cosine is 5 up. 2, 3, 4, 5. And your amplitude is 5 up and 5 down. So let's say 1, 2, 3, 4, 5 is pi over 2. 1, 2, 3, 4, 5 is pi. They're supposed to be here. Pi over 2. Pi. 1, 2, 3, 4, 5. 3 pi over 2. 1, 2, 3, 4, 5. 2 pi. So these divisions are not supposed to be on the middle line. They're supposed to be on x-axis. Okay, so your cosine starts there, then it's gonna cut there, it's gonna go down there, it's gonna go up here, and it's gonna end up at the same elevation on top. So now what you have is the cosine graph. It does what cosine graphs do, and this is your wave, right? So the top of the wave on the ocean or whatever, and look, this is 0, 5, 10. Yeah, the average value is 5. It's a middle because it's perfectly symmetric trig function. And the amplitude of the whole thing, right, is 5 each way, so 10. So if this is in feet, yeah, these are some serious wave, 10 feet tall wave. From the lowest point of the wave to the highest point of the wave is 10 feet. You don't want this to be 10 meters because 10 meters is 30 feet, right? We all know what 30 feet wave can do. Technically erase everything in front of it. But the average value is 5, and we can actually see that. Now we did calculate that using our formula we just learned, but in the essence we can actually very easily confirm this by just graphing it using basic knowledge from pre-calc, from trig. All right, so those are the two problems that we did for average value, and now I'm just going to rewrite average value in terms of mean value theorem for integrals. And that one simply says f of c is actually equal to the same integral. Everything is the same. because it's a mean value theorem, right? Not mean as evil, but mean as the average, right? So if f is continuous on interval a to b, there exists a point c in a b. It's the same deal with the other one. So there is a point at which they they're equal, and it's actually equaling areas. But look, this is that point. So your c is equal to pi over 2 in the case of trig up there. All right, because when c is equal to pi over 2, you get your y equals 5, which is the average value. So that connects with the formula below. Again, there's nothing new to learn here. It's the same formula, exactly same calculation and everything. It's just the only thing that we are focusing on here is that there is this point, right, that you can use to calculate also y. And have them equal. I mean, that's technically what it is. That's it. I hope you're not disappointed. We reviewed the setting up the areas and what happens if the function dips below x-axis. Then looked at these other formulas, did even and odd, which I call quality of life improvement, right? And then you have your average value and the mean value theorem, which is the same, literally it's the same function. If you were to apply mean value theorem to the cosine problem, right, you would have your f of c is equal to 1 over b minus a integral a to b of f of x dx. You would say, oh, f of c, my f was that function, right? So you have 5 times c plus cosine c, you plug that in. On the other side, you have 1 over 6 minus 0 integral 0. No, it was not 6 0, it was a negative pi to pi. So pi minus negative pi, there we go, much better. And then negative pi to pi of 5x plus cosine x dx. Now we already calculated that all this mess is 5. So you have your 5c plus cosine c is equal to 5. We already did this. When you divide both sides by 5, you get that c plus cosine c is equal to 1. And now you have to solve this equation. So that's going to be cosine c is equal to 1 minus c. Now this is not an equation that you can solve by algebraic means because it's combining polynomial with the function. So you actually have to graph this or use the software. So graph or use approximation to solve. Because, as I said, you have transcendental trig function on one side and you have a polynomial on the other side, and they don't play nice. Because you can, the way to solve equation with the cosine c over here is you have to apply inverse cosine. So if you apply inverse cosine here to kill the cosine, you bury this c under inverse cosine. So there is no way to, have both c's on the surface to calculate them. So always one is buried inside. Now, what I talked about earlier with those power series, yeah, you turn this into an approximated polynomial, which is this part, and then you calculate easily because then you have polynomials on both sides. But again, that's going to be a Calc 2 technique, we are not equipped very well in Calc1 with methods to solve this. So we can just chill and, go, do different problem or something, because this is not a situation that you can win. All right. But you can definitely graph both of these functions and look for their intersection. And whatever x they intersect at, that's your value c. But again, more on that and better options and problems and everything in chapter 11, right, of Calc 2. So I don't want to bother you with those things now. That's it. Questions, concerns, anything? I will say bye to YouTube.